let's talk a little bit about residual effect. Residual effect is a property that's talked about with de-icers. Generally, it refers to how long does that de-icer keep on working once it's been applied. How well does it resist being diluted by ongoing precipitation or being abraded off the road by traffic action and that sort of thing. If a de-icer's got a longer residual effect, then we should be able to apply de-icer less frequently and therefore lower our application rates again. Well, at the moment, we do not have any kind of standard industry test to measure residual effect for highway de-icing. It would be nice if we did. And so we've been doing some work to try and move in that direction. And even though the highway industry does not have a residual effect test, the aircraft de-icing industry sort of does. The aircraft de-icing industry has a standard test method that's called the WSET, which stands for Water Spray Endurance Test. And it is used to qualify all aircraft liquid de-icers. Basically what the test involves is they take aluminum plates that are held at an angle that simulate the wings of an airplane. They apply de-icing liquids to these, and they put them in a test chamber, and they start exposing them to steady, freezing precipitation. And they just say, okay, how long does it take before that freezing precipitation starts to freeze to the aluminum? That enables them to calculate something that they call holdover time. The holdover time is a measurement of basically, after my plane's been de-iced, if it's snowing outside and I'm waiting to take off, how long can that plane sit there and be exposed to freezing precipitation before I have to de-ice it again? That is, essentially, it's a measure of residual effect, so to speak. It's a measure of how long the de-icer keeps working. So we thought, can we modify that test to better simulate the somewhat different conditions under which highway de-icer liquids are used? So we did some work together with the Anti-Icing Materials Laboratory with the University of Quebec. They were actually the lab that developed the original aircraft de-icing test. And we published this research in the Transportation Research Record, and it was recognized actually as the best paper by the TRB Winter Maintenance Committee last year, which was kind of nice. And I just want to give you a little peek at what we found. So we modified the test to better simulate highway conditions. So one thing we did was, instead of using aluminum plates, we coated the aluminum plates with a layer of asphalt cement. So we had a surface that was more like an asphalt road surface. We left aggregate out of the coating intentionally because we wanted to avoid the greater variation that we would see caused by the roughness of an aggregate containing surface. And we wanted to be able to have an easy way to look at differences between different chemicals. We used a test temperature of 15 degrees Fahrenheit, chosen to be sort of in the middle range of temperatures that would be experienced under de-icing conditions. And we did not tilt the plates as they do in the aircraft test. We left the plates level. And the idea here was we didn't want liquid running off the plate. We wanted all the liquid to stay on the plate so that we knew we were comparing equal application rates. The aircraft test, they basically apply an excess of liquid. Just like when you see when an airplane gets de-iced, they're hosing it down heavily and excess liquid's dripping off. That's not how we use liquids in the highway world. So we applied a specific application rate to each plate, so we're comparing apples to apples in our application rates.